In this chapter, we want to look at how CSE actually processes the lines and actually to get our machine moving. At the moment, it does not yet move. In all the training sessions, I will use external file simulation, so with tools simulate machine code file, since this makes my life easier to create NC programs and to show you the different behavior of the machines. So instead of using a post-processor, I will just use handwritten files. Like I said, this just makes my life easier to show you the different ways of how to program something and how CSE reacts upon that. Instead of always going through tools, simulate machine code file, it's also convenient to just customize that button. Go into commands, locate the tools toolbar, look for the simulate machine code file, drag and drop it to one of the toolbars, for example next to simulate machine, and then you have a shortcut to get there much faster. So first of all, I will create a test program and show you what happens if you. So far our MCF is essentially empty besides the access configuration, the channel configuration, and telling CSE which controller to use. But if I use a G0, X0, and then X100, and then a M30 for program end, I will most likely get error messages, and that's what I would like to show to you. So I edited the program, I will select it, or open ISV, and then I can use the step button to actually start simulating, and now I'll already get an error message that CSE tells me that G0 is an unknown metacode, he doesn't know how to handle that. So that's what we will address next, how to customize that. Before we dive into the details, based on the PowerPoint, I would like to show you how CSE actually processes files, and that can be easiest done based on the CSE architecture. So we have 3 or 4 components. On the left side you find the application, so in our case ISV, with the 3D world model, the machine model, the ISV dialog and the simulation loop, and the VCR buttons that control whether you would like to simulate forward or backward or make step modes. That's controlled by the VCR. And then of course the analytical functions like the material removal or collision detection that can be used to update the material removal and so on. The component in the middle is the CSE, the Common Simulation Engine, with motion planning and so on. And the third component are controller DLLs. So for every controller we have a separate DLL. You can actually find them in the file system if you go into the EGI directory of your NX installation and search for libcam. Then you will find libcam CSE. That's the DLL for CSE. So in this picture, the middle part. And then you will find a couple of DLLs with controller names. So FANUC, Maho, FTX, 840C, 840D, Standard, which is DIN ISO, Heidenhain TNC. And these are the controllers that you can use in conjunction with CSE. So if you find something that is not working, you can also get some patches on those DLLs. So the only thing you would have to do is to create a backup of the 840D DLL, for example, and put in a new one, just that you know where the files are located. So for every controller we have a controller DLL. Then of course we have our configuration files, the MCF, and if you use our out-of-the-box content, also the CCF libraries. And of course our NC program, whether that's an integrated simulation coming from the internal post, or like we do it here in the training using the external simulation functionality, doesn't play a big role. The mechanism is the same. And the NC program is not only the main program, it can also be sub-programs that are started from the main program, and it can be cycles like standard Siemens cycles. These are also in the end program files that get executed during runtime. So if you want to simulate our main program with the G0, X0, the first thing that happens, it goes through a parser, so-called parser. The parser in CSE uses standard technology that's called LexYAC. That's also used to produce compilers for other programming languages. And we've used this mechanism that allows us to syntactically check the file and read it into blocks, or we call it metacodes, and command calls. So to really chop the NC program into small segments that can be that you can then assign with a functionality. The difference between a metacode and a command call is a command call is something that does not need a configuration. So for example, assigning a variable a value, or R10 equals 100. That is something that does not need a configuration. Assigning a value to a variable is something that CSE knows how to handle. So that's something where you don't need a configuration in your MCF file. So that produces a command call. Everything that requires a configuration will produce a metacode. And to define the behavior, you will use the MCF file. So for example, on our G0, CSE will provide or produce a metacode G0. It will then query the MCF file to figure out how to behave upon a G0. Here you can define that using a long list of functionality that is defined by CSE. That's so-called kernel command, and we will use the documentation that lists all these extensively. So with these commands you can, for example, assign or tell CSE that a G0 is a linear movement in rapid mode, while G1 is a linear movement with a feed rate. So in the MCF you will make this assignment. Of course, CSE will also use the channel configuration and the access parameters that you've defined in the MCF file. And then for our line, for our example that we had, G0X0, also the X will produce a metacode with a value 100. Also this will be must be configured in the MCF file to tell CSE, okay, X100 means move the X-axis to a value of 100. This will be done for every line. So for a line, all the metacodes will be produced, and if all the elements of the line are processed, then CSE has enough information to do motion planning for this line, and really only this specific line. So the NC program is executed by CSE line by line as it is on the real controller. So if the line is entirely processed and through the MCF file CSE knows what should happen in this line, CSE starts the motion planning. That basically means look up the axis profiles and try to see how fast the axis need to accelerate or decelerate to make a linear movement, determine the overall time it will take to do that. And then basically CSE will provide the axis values, the calculated axis values to ISV, so that ISV can update the graphics, move the machine, and do material removal based on that. In certain cases, like I said, to configure behavior you can use the kernel commands. That's really a long list of functionality. In some cases it is possible to extend that based on controller specific functionality. So some controllers like the Rexroth MTX or also the Siemens 840D, they have some functionality that is not available on all other controllers. So that's why there's also the capability to extend this list with controller specific kernel commands. We will also make use of some of those a little bit later.